Hello, welcome back to another video of Math of the Day. It is currently May 27th, 2025. Today we will be deriving the Pythagorean theorem and finding where it comes from. We will also use water to show how it works. The basic recap of last video was Pythagoras found out that the hypotenuse squared is equal to the sum of the legs squared. Also, if you haven't seen the last video, pause right now and watch it. It has vital information that you need to know for today. The video will be in the description if you want to see it there. Hopefully you watched the video, so let's continue. Instead of saying that the hypotenuse squared is equal to the sum of the legs squared, we can write each side of the triangle as a variable. So let's represent the legs as A and B, so I'll just say 3 is A, uh-oh, my marker, 4 is B, and we can label the hypotenuse as C. And the order of the legs does not matter because these could be interchanged because they're both legs. So now that we have addressed each side as a variable, let's rewrite what Pythagoras stated. So I'm going to actually bring this down here, and we can rewrite this as C squared, so the hypotenuse is equal to the first leg squared, which we could just do A squared, plus the second leg squared, which would be B squared. So C is equal to A squared plus B squared. So let's switch each side of the equation so that we get A squared plus B squared equals C squared. Does this rule look familiar? I'm sure all of you have at least seen it once or twice before. This means that A squared plus B squared is equal to C squared, and this is the Pythagorean theorem. We can do our same demonstration as the last video with the park path. Let's just change the legs and hypotenuse to A, B, and C. As you can see, 3 is A, so we can plug this into our equation. So 3 squared, and then 4 is B, plus 4 squared should equal C squared. 3 squared is 9, plus 4 squared is 16 equals C squared. So 9 plus 16 is 25, which is equal to C squared. We can take the square root of both sides. So the square root of 25 would be 5, because 5 times 5 is 25, and the square root of C squared is just C. So C equals 5. We can also draw this formula out as well. 3 squared can be drawn as a square with side length of 3, and the area of that square would be 9 units because 3 times 3 is 9, and we'll just be using units as our measurement. And we can also do the same for this square. This is a square with side length 4, so 4 times 4, or 4 squared, is 16. 16 units squared. Yeah, let me add that little square mark. So we can show that if we add these two squares, it should be equal to the area of the big square. So 9 plus 16 would be 25. So the big square, or the hypotenuse squared, is equal to 25 units squared. So now, in order to find the hypotenuse, we must find the side length of the square with 25 units as its area. So, in order to do that, we have to find the square root of 25, which we've addressed this earlier. The square root of 25 is 5. So, our side length is 5 units. So we just proved how we can draw out the Pythagorean theorem to see how it works with actual squares. And now let's prove the Pythagorean theorem using water. Right now I'm in YouTube and I have a very cool video to show you that proves the Pythagorean theorem using water. Let's watch it. But before we start, we can see, just like a little bit ago, we can express A squared, B squared, and C squared as actual squares. So now let's watch. I want to stop here because when she flipped the triangle, you can see that the areas from a squared and b squared combined and equaled c squared. This is the same thing as a squared plus b squared is equal to the total area of c squared. This shows how the Pythagorean theorem is proved using water. Now we can watch the rest. In summary, we learned where the Pythagorean theorem comes from, as well as proving it by watching a fun demonstration using water. I want to end this video off with a practice problem for all of you. You don't have to do it, but I encourage you to do it. I want you to find C where A is equal to 5 and B is equal to 7. Just know that your answer for C is not going to be a whole number. It's going to be a weird square root. Like in our past triangle where we've been learning the Pythagorean theorem, we've been ending where C equals 5. But for this one, C is not going to be a whole number. It's going to be a square root. So when you express your answer, I want you to express it as C is equal to the square root of x, where x is equal to a squared plus b squared. So let's just say you were solving a Pythagorean theorem and you have, let's just say 50 equals c squared. When you take the square root of both sides, you'll get c equals the square root of 50. But since 50 isn't a perfect square, you won't be able to simplify that down to a whole number. So don't worry about simplifying it. You can just leave it like that. I hope you have fun with the practice problem. Thank you for tuning into Math of the Day, and goodbye.